video, we move to the last programming challenge for chapter 2. We will explore the relationship between the Fibonacci sequence and our golden ratio. Fibonacci sequences are one-dimension series of the number with some such kind of the patterns. The number is the number I is in the series the sum of the two previous number, which means it's the summary of I minus 2 plus I minus 1. The number in the position, this one, and the successive number in the series display an interesting relationship. When you increase the number, the terms, the ratio of consecutive pairs of number are nearly equal to each other. So first, they may have some variable, so like this one. So the previous ratio of number divided the next number, and gradually it will make into the very stable line. This stable number is the code is 1.618, which we call this golden ratio. This golden ratio as a const. They have infinitive these digits. It's used extensively in music, architecture, and natural. If you have some lots of the art, those products, you can see this golden ratio in many places. So for this challenge, let's back to our programming challenge. We need our program to be written that will plot on a graph the ratio between consecutive Fibonacci number for maybe it's 100. Because it's getting very stable, so 100, 1000 is not showing big difference. So it's already can show you the pattern. And you may find the following function is return a list of the first n numbers of this Fibonacci sequence. So we will use this to implement our the program. So before that is let's first do the preparation, and let's make our, let's see, so I close all, and we create now is 0205, and number 5, we put this as code that is Fibonacci and golden ratio.py. So we use that, and we put here the ratio where we see the relation between Fibonacci sequence and golden ratio. Yep. So we will make those, and today is the 14. So first, definitely is let's import our needed this library first. .py plot splt. So that will definitely useful for our plotting. So, and then this we make this Fibonacci function. So this function is get our input as n, then we output the list of this n. So if n just 1, then we just return our list with 1. So and if n just 2, so the first 2 of the list is defined by this already. So because that is our prerequisite for Fibonacci. But if if that's not there, then that means is n is more than 2. So let me see. So then we give one variable. A is the first one, B is the second one, and we predefine the first two numbers are 1 and 1, and then this we make our series equal to A as the first and B as the second. Then we will have this iteration to do. So for I in range n, so if we want to go to n, then we see the C we defined is the third one, is based on the Fibonacci sequence rule. So C is A plus B, and then this we push C into the series list. So append C, and after that is similarly like we switching the two numbers. Now we have ABC, and now we should drop A and make B to A and make C to B. Then we have a new A and B. So A is B, but ensure you have the correct sequence. If you put this B to C first, then this B is gone, and but we still need B. So now we have a new A and B, and then the I will move to the next. Then we will have those parts. So let's make our the eighth name. Let's print this Fibonacci. So is min and print Fibonacci, let's see, 10. Oh, it's none. So we return. So we haven't returned this. So after that, return series. Yeah. Yeah, correct. 1, 1, and these 2 is 1 plus 1. 3 is 1 plus 2. 5, 2 plus 3. 8, 3 plus 5. So now let's try to maybe plot this. Is a depth draw graph. So if we want to get x and y, and then this we have this Fibonacci. So we already have that. Let's comment this, and x. Let's see. So we make is x in range. So we put that is in range equal to. Let's see. So how we can make those parts. So if we want to do this, we will generate something. So if let's see. So for range n. So yeah, let's make that. If everything is in range n, then we have our make our list first, and then we make the y in the second. So that is the thing. So let's back to our program. So it's this one. So x equal to this, and the y, and for I in range n, x is the append I. So then I got a list. Then is y equal to Fibonacci n. So we gave our n. So let's see. So input n is integer input. The Fibonacci sequence till which number. So I receive this, then if that Then let's see. So what's the reason why here is the issue? If, and then we will draw this one. So we will have this plot TLT dot. Here is what we have is the plot. You see here is when we draw this, we just need the x and y. So now we have x and y, and also we give this marker equal to O, and we make the show. So now we have this. Let's make this x, y. Let's see, I want 10. So what's the reason? X and y must have the same first dimension, but x has, so this one, so because it's for Fibonacci, so we get 12. So if I have the n, so for I in range n, so I have A and B. So here I should plus 2. Then let's run this. So let's give 10. Now I should have this. So these are the Fibonacci, the sequence first. So let's see. So I put this TLT dot title Fibonacci sequence in line chart. So now we have this run. So if I put that in 100, let's see what that looks like. It's a increase after the 90 or 95 is hugely is increase. So that is this Fibonacci. But if I put that lower, so let's say run, maybe 50, then you can still see. In the left is 0, and here even this 3.0, 2.5, but here is times 10. So that is already have the scientific parts. So let's make that slower. So you can see it's getting very the peak is even this go to 25 is already 120,000. So that is increased quite a lot. So let's make it another just 15. So you can see how much 15 is go to the 1600. So that is the Fibonacci. So let's copy this one. So maybe I make our rename. That is first we know is what are the Fibonacci looks like. Then we go to our challenge. Yeah, so our challenge is not only to draw the, no need actually to draw the Fibonacci, but we want to see the ratio of the Fibonacci. So that is we may not need this the basic the draw graph. But let's make another is the plot ratio. So this we will give our series. This series will be our ratio. So let's see, ratios equal to empty first. Then this we will have for I in range len ratio. Series, we get this series and plus 1. Oh, minus 1. Then, oh, I forgot this. Then the ratios append with this series I plus 1. So we use this next divided series current. So I. Yeah, because we use the I+1, so we should have this -1 as the boundary. And then this we can plot the title. First is we need to the plt dot plot. So these are just the plot ratios. And then next is plt title. We give this title is the ratio English between Fibonacci numbers and golden ratio. So that is our title. And also we have the label. So X label, we put that is the number. And the Y label, we give that is the ratio. And then we finally get this show. So these we can comment that because we don't need that. Then let's write down our primary code. Code is these are not the way we need to do. So we can get the n still, and we see is how many. And then the once we have that is we directly have the series. Series is the Fibo n. So n is already an integer. And then this because we just need to transfer the ratio, so we just plot series. So let's have a look. Okay, if I see I just have a 3. So you can see the first is 1, because 3 is 1, 1, 2, right? So the first ratio is the 1 divided by 1, and the 2 divided by 1. So it's getting 2. And the next is getting the slower. So, but this 3 means I have the total is 5 number. So the first is 1, second is 1 is already predefined. So, and we have 3. The third one is 2. So its ratio is 2. The fourth one is interesting. Fourth one is 1 plus 2 is 3. So 3 divided by 2 is 1.5. So you can see it's a clear 1.5. And 2 plus 3 is 5. So it's the next ratio is 5 divided by 3. It will be the 1.666. The cycle is we normally see is 1.67. So that is more than 1.6. So that is the in the when the n is very small, this ratio is quite the changing is quite a lot. But let's increase to have some observation. If we go to 5, then we have total 7 numbers. So we have still this 1, 2, 1.5, 1.5 and 1.67. Then this one is 3 plus 5 is 8. 8 divided by 5 is 1.6. And 5 plus 8 is 16. 13. 13 divided by 8 is 1 and 5 eighths is 1.2625. So if you're familiar with that, quickly the calculation by heart. So that you can see is it's still waving, but it's this wave is getting slower. And then let's starting to make double. So now you can see it's getting the stable, and now it's for our sample is we gave 100. Then we have this the sample lines. So it's a jump quite big, and wave is dynamic, but very quickly is stable, and this stable line is in this 1.8618. So that is the golden ratio. So now we have the way to show this ratio is really getting stable through this line. So I hope you also get this the same the charts by your the own the coding. So we start is we finish the whole number the 2 chapter, and from next chapter is we will move the statistic using the data to describe those. And before we closing this video is let's see. So look at those content. So first we will talking about the mean and the median, and then find the mode to create a frequency table. This frequency table is normally still represented by a percentage, and then we measure the dispersion. Calculate the correlation between 2 data sets. So until now is we normally talk one data set, but if you go to multiple data sets, for example, we have touched base a little bit is we have the New York City's temperature series, we have the Brisbane's, we have Amsterdam's. What's their relationship? So are they have some the positive relationship correlation or negative correlation? So that is in the same type of the data set, but if we have a list of the temperature, and another is this list of these locations, the code. For example, in these the locations in globe. So what's those the longitude related to the temperature, or maybe the height in a big mountain, and you describe is the numbers of the trees per category. So are they have some correlation to this height level in our mountain? So those are the ways using 5 subchapter we try to find is some way we can find out or calculate in mathematical way of the correlation. And then is once we have those correlation, actually we have 2 data sets, then we can we will introduce the scatter plot. Scatter plot is just in 1-2 dimension space. You have the different the data with the correlation, and they put in the different dots. They are not like of a line chart. You connect the dot. Those this scatter is show you our distribution concepts. And then the reading data from file is one thing. So, but if you take chance to, you can learn from my another video series about the Python with Office. So we have numbers of the ways for Python to read from the files, text files, the Office format files. But here we primarily talking about the text-based file because we are focusing on the statistic, the analysis. And then we again is we have 5 challenge topic to discuss in the end. So congratulations for you is to finish together with me about chapter 2. If you like my video, is please subscribe my channel. That will give me the encourages to make a more useful video for you. So and then is I will welcome you to come with me is on the next chapter 3. So see you next time. Bye.